Hi, this is Miss Ertl, and this video is about kinetic energy and potential energy. Um, Energy is one of those things that you've probably heard the word a lot. You use it when you talk about, like, I'm really hyper, I have a lot of energy, things are moving really fast. But in terms of physics, the definition of energy is the ability to do work. If you think back to the unit on work, you would maybe remember that when work is being done, things have to move. And so energy is in a sense, the ability to make things move. It can be something that is already moving, or it could be something that needs a little something to get moving, but that is what energy is. Some examples: a gust of wind, it moves objects in its path. A piece of wood in a fireplace that is burning has energy. It produces heat and light. And now that one might not be as easy to see because, like, what's moving in that example? When things get hotter, the atoms start moving faster. And so that's where the work comes in terms of burning. You have energy, you can change the motion of your own body. And things inside your body are moving even without you trying. You have the blood that is pumping, you have air moving in and out of your lungs, you have muscles that you can move your body parts. All of those require energy. Because energy and work are very much related, the units for energy is joules, which is the same units as work. You need energy to do work, and so they measure them in the same things. Also, something that we'll talk about more in a couple weeks is that doing work, when you do work on an object, you are actually transferring some of your energy to that object. And so because of that connection, they are measured in the same thing. This week, we're going to focus on two major forms of energy. We have potential energy, which is stored energy. So something is not moving, but it could be soon. For example, this apple that they're pointing to right here in the tree is sitting still in the tree, but it could move if the stem breaks. And so it can move, which means it has potential or stored energy. For most of this week, we are going to focus on gravitational potential energy, and that is actually one of the types of potential energy that this apple has because it is off the ground. Next week, we'll talk about the other forms of potential energy as well. This other type of energy you can have is something called kinetic energy. It is the energy that moving objects have, and so the apple, as it falls to the ground, has kinetic energy. At this point, it would still have potential energy because it's not yet on the ground, and it would still have potential energy until it hit the ground. And so you can sometimes have objects that have both going on at the same time. So we'll start here with the formula for gravitational potential energy. It can be shortened to GPE, as it says. You have the mass of the object times the gravity of whatever body you are on times the height off of the surface. The picture in the lower left shows that you can measure gravity to a different, or the gravitational potential energy to a different surface. So you can measure the gravitational potential energy of a block that is off a table, or you can measure that block off the ground. You just have to talk about where you are measuring to. The gravity piece, if the problem mentions that you are somewhere else in the universe, make sure you use that gravity. Otherwise, if it does not mention a gravity, you would always assume that you are on Earth. And the gravity here on Earth is 9.8 meters per second squared. If you remember back when we did acceleration and Newton's second law, you can write that as meters per second, m/s/s, if you don't like finding the squared on your Chromebook. What that equation, again, so just a reminder here, gravitational potential energy is stored because it's above the ground or because above a surface, because gravity can pull it down, thus gravitational potential energy. It's directly proportional to mass, gravity, and height, which are, again, the three things in the equation. And if you don't know what that means, if your math brain isn't working real well right now, you could know that gravitational potential energy goes up when any of those three items goes up. So if the gravity becomes larger, then the gravitational potential energy becomes larger. If it's higher off the ground, there's more potential energy. The inverse is also true, so that if one of them goes down, the gravitational potential energy would be less. So the lower an object is, closer to the ground, the less potential energy it has. Some math problems, just some example math problems. We have a 7-kilogram cat sleeping on a tree branch that is 2.8 meters above the ground. Calculate the gravitational potential energy of the cat. So in my class, just remember that I expect you to show your work, which starts by showing the equation that you're using or the formula that you're using. This unit, it becomes really important because there are two different equations that you could be using. So make sure that you show me which one you're using. Then you plug things in where they belong is the second step I expect. So 7 kilograms goes in for the mass. The gravity is not mentioned, and so I would assume Earth, 9.8 meters per second squared. Height above the ground, 2.8 meters. When you go to solve this, it is extremely important that you remember that this 2 goes with the seconds only. It does not mean I square 9.8. Do not square the 9.8. In your calculator, it'd simply be 7 times 9.8 times 2.8. So you would get 192.08 joules. Okay, so just to be aware of that, no squaring here, just straight up multiply them together. This example, if you're looking, obviously is not on the Earth. You have a 120 kilogram astronaut that is wearing the gear, standing in the landing module 1.75 meters above the surface of the moon. If the gravity on the moon is 1.62 meters per second squared, calculate the gravitational potential energy of the astronaut. You do this the same way as the last one. Start with my gravitational potential energy is equal to mass times gravity times height. The mass is 120 kilograms. The gravity on the moon is 1.62 meters per second squared. The height off the surface of the moon is 1.75 meters. Multiply those together and you get 340.2 joules. When you have something that is moving, you can calculate kinetic energy. Kinetic energy is 0.5 or 1/2 times the mass of the object times the velocity squared. Yes, you actually square the velocity. This is, just reminding you that you could calculate the kinetic energy of a paper airplane, but realize again, because paper airplanes fly above the surface, this one would also have potential energy, but oftentimes I'll only ask you to calculate one of the two, not both. So just a reminder, it's moving. Kinetic energy is objects moving. Proportional to the velocity and the mass. A little bit different though, because the velocity is squared, the velocity makes a bigger difference in kinetic energy than the mass does. So just keep that in mind. Again, that means that the kinetic energy will go up when the mass goes up or the velocity goes up. It goes down when the velocity goes down or the mass goes down. All right, for math examples, a 2.4 kilogram rock is at the edge of a cliff above a lake. The rock becomes loose and falls toward the water below. Calculate the kinetic energy of the rock when its velocity is 7 meters per second. Same steps, just a new equation. So kinetic energy is 0.5 times mass times velocity squared. Plug things in where they belong. 0.5, mass is 2.4 kilograms. Velocity, 7 meters per second squared. Notice I put this in parentheses. If you do not put it in parentheses, it looks like an acceleration, like it's just seconds squared, but you have to square the entire thing. If you don't want to try to find this weird little squared on your Chromebook, you can just put 0.5 times 2.4 kilograms times 7 meters per second times 7 meters per second. Because when you square something, it's just multiplied by itself. So your choice for that. If you put like a big 2 behind here, I get it. Or you can do a lot of copy and pasting. That's what I do on a lot of my assignments. I do it once and then I copy and paste wherever I want it to be. Remember to square the 7 first. So you'd have 49 times 2.4 times 0.5, and you would get 58.8 joules of energy. Back to the cat sleeping in the tree. What if the cat falls? How much kinetic energy will this cat have when the velocity is 5.5 meters per second? Again, 0.5 times the mass times the velocity squared. 0.5 times 7 kilograms times 5.5 meters per second, and square that whole thing. So if you're doing this on a calculator, either use the squared button or do 5.5 times 5.5 times 7 times 0.5. gives you 105.88. I believe this one and maybe one or two other ones, you actually, when you put it in your calculator, you get a longer decimal. Just remember, you can put the whole decimal if you want, or you can do 2 decimal points and then round if necessary. Hope this helps.